Welcome to Altair How to Learning video. My name is Shravan Mote. I'm a technical engineer at Altair. As you may already know, Altair has a standalone fatigue application called HyperLife, which is very easy to set up and solve structural fatigue problems. HyperLife also supports weld certification using standard codes such as FKM, ERO, TVS 1612, and more. Yeah, please refer to HyperLife documentation in the video description below, and please reach out to HyperLife support if you have any further questions. But today's topic is how to set up a fatigue subcase using Altair HyperMesh that can be solved by OptiStruct solver. Yeah, setting up subcase, a fatigue subcase like any other subcases like FRF, static, or random subcase, which can be very advantageous when you are optimizing for a fatigue responses such as damage or life. So you can create a responses and you can optimize using any structural optimization problems. Today, I'll be showing how easy to set up a fatigue load case within Altair HyperMesh using the fatigue process manager. Yeah, HyperLife and OptiStruct fatigue solvers both are similar codes in the backend. So today I'll be showing using our 2023 version to show this demo, and I'll be using an automotive example, a automotive subframe example, which has 12 subcases, which are static subcases, and I'll be using all those 12 subcases to set up a fatigue event. All right, let's get started, shall we? All right, let's proceed. In order to set up this fatigue subcase within HyperMesh, launch any latest version, 2023 or 2024. So this is a very latest GUI, and we have advanced features in the latest HyperMesh. Yeah. So you can on the top ribbon you can see, click on the Analyze ribbon here and select the Fatigue PM. It's a Fatigue Process Manager. Once you click on that, you can see the process displayed in the model browser here in the tasks sub window, and you can follow this process to set up a subcase. It's very easy to set up, as I was mentioning, so you can just follow these steps to set up. So click on the working directory by selecting this folder. Select any. So I have a folder on the desktop, Analyze 2, and just selecting that folder, and then just click on Run Tasks. So in here you can see the Fatigue Process Manager and Models of Proposition. There is a different way to set up that. That's not the video content. So today we are setting up only the EN based fatigue analysis. So for that you just need to select the Fatigue Process Manager and select the model that you are interested in to perform. So for this example, I'm using a cradle or an automotive subframe model. So just select that model and just click on OK and then import. And the model is imported. Again, you can just change few settings here for a good visualization, and then just click on Run Tasks. So the model is imported here, the fatigue model is imported here. So just we want to create a subcase, correct? So we have to just type in the name for that of fatigue subcase 1, and then click create. So the fatigue subcase is created, and whatever the steps that you follow next is related to this fatigue subcase 1. And if you wanted to create an include file with all these fatigue cards, you can click on this here, and then just click on run tasks. Here we are, as I said, like we are interested in EN based fatigue analysis. So click on EN, and in the EN based, you can see there's a uniaxial, multi-axial. So currently we are looking for a uniaxial, and there are different stress combination methods available. So you can use any of those. But today I'm using only absolute max principle as a stress combination method. And FE model inputs, there are different units. So I can selecting MPa here. And we have a different mean stress correction factors. So I'm selecting Smith-Watson-Topper a mean stress correction factor as a mean stress. And plasticity correction, Neuber is a plasticity correction factors. And the certainty of survival is 0.5. And the rain flow loading information, if you have a load versus time history, you can just select the load. If you have a stress versus time, you can select stress. And then the gate, just putting a 0.2 here. So what this does is it will eliminate load damaging cycles within the time history, so that it can run faster, and it eliminates some of the load damaging cycles there. And you can see there are some other options that are available, seam weld options, spot weld options, and these are for the vibrational fatigue options. So currently what we have is static subcases, so we are not evaluating for any seam weld or spot weld or a fatigue subcase or a vibration fatigue. So we are only using static subcases. So we don't have to select any of these options, and then we can just click on run task. So here in this area, in this step here, we can select the materials and assign the materials to the properties. So we are creating here an SN curve or an EN curve in this step. So I'm interested into performing a fatigue for this part here that you can see, and for that I have a material of 410. So all the materials that you have in the model are displayed here, so you can create any SN curve or EN curve for the material that are already in the model. And then the stress, the units are MPa, and so you can just here in the ultimate tensile strength, you can just type in the 410. That is the UTS of this material here, and then click on this the check button here, and then click on this. Select estimate by UTS. So estimating the EN curve based on the ultimate tensile strength. So this is a steel material, so I'm just selecting the steel material here, and then just click on estimate. So all of these fatigue properties or that are necessary to create an EN curve are automatically calculated once you click on the estimate by UTS. And there are some more properties here. Just selecting the amplitude instead of range, and then so yeah, please adjust these settings if necessary. So I don't want to change anything for this example, so just click on OK here, and then click on plot EN curve. So this will automatically populate or create an EN curve based on the properties that we have estimated by UTS. Click on OK, and then save. So once you've done that, it will automatically, the material properties are automatically saved under this material here. And then now we have to assign the material to the property, right? So select this, and I'm interested in the material, the property of this one, and then I'm creating a PFAT. The PFAT is like where you need some corrections based on the surface finish or temperature and those kind of stuff. So clicking on create, so you can see this. So there are a few properties that you can select. So I'm using a polished finish, and if you want to do any treatment or surface treatment, you can select these. And this is a fatigue strength reduction factor. So you can just click on 1 if you want. If you want, you can type in any lower number or a higher number if you want. So click on click on close here, and then and you can see that, and just click on this update. So for this material, for this property, this is the surface finish. This is assigned to this property here. And click on close here, and then click on close here. So you can see here, this is a P shell that we are interested in, and so load collector 1 is what PFAT that we have created for the surface finish and all those information, and then the material is assigned to that, and then we can proceed to the next step. So we are only performing fatigue for this property for this demo. Click on run tasks here, and then here we wanted to add the loading information. So for example, if you have an RSP file or any other time versus load history information, you can load it here. So I have an RSP file that I wanted to load, so you can just say RSP loading. Okay, and just I have an RSP file here, so select the file here. So I have a 12 channel, so in the RSP file, I'm just loading into that, and click on import. Once you import this, you can see the channels information here, and click on OK and save. So once you do that, you can see all of these channels are imported. So you can click on mins and max to see the number of points, the max and mins, and all of this information. So it's the loading is actually changing from plus to minus, +1 to -1 in most channels. And you can select any of these channel to plot. So you can check on that and click on close here. Alright, so once you have the loading information, then you can just click on run tasks. So now this step is you're connecting connecting the channel to the subcase. So click on add here. So I'm selecting all of these channels that we have just imported, and then these are the subcases that are available in the model, and then click on auto here, and then just click plus sign here. So this will automatically link the channels to the subcase in the same order, And if you want to scale or divide based on the units, you can do that. So currently my loading is a plus or minus 1, and I have a unit loading in the subcases. So I want to scale my channels to 10,000. So that I can see some damage on the parts for this example. So okay, so once I have that, so this is an event 0. If you wanted to change or increase the number of repeats, you can do that. For now, I'm just putting number 1, just one repeat. And then click on save. Now, yeah, this automatically, as I'm saying, this will create an event, event 1. Yeah, so you can just click on run tasks now. Yeah, before even so now this step is to save the model, but you wanted to verify if all the cards have been created. Just go on to the model browser again. Go on to the load collectors here. So mainly what we have to verify is a fatigue sequence. So the fatigue sequence is you can see there is event 0 has been created. So go to the model browser again, and fatigue parameters is the other one that you have to verify. So here in the EN, so this is EN based approach again, and so you can select which type. Is it a uniaxial or multi-axial? So currently it's an uniaxial. Yeah, so all of the absolute max principle, Smith-Watson-Topper mean stress correction factor, and all of these are in whatever the information that we inputted. So we have a gate of 0.2. And certainty of survival is 0.5, and we have not selected any spot well parameters, so we don't see them anymore. We don't see them here. And then once you go here, fatigue definition is another one that you can check. So you can see the fatigue definition is yeah. And so here, you can see the top stress fraction elements with combined stresses not in the top fraction of each MATFAD group will be screened out and have no results. You can select these to as a 0.2, so it will eliminate some of the elements. Yeah, so you can some of the elements in there from the fatigue evaluation. And then so select once you go to the model browser and see if the fatigue events you can see there are 12 load cases here. So yeah. All right, so the one more step that you can check is the materials. So go to material here. What we are assigning the EN curve is to this, for this material here, the 410. So you can see in the MATFAT, MPAs, all of these are, so in the EN based, you can see this material has been defined. In the EN, you have a material based, and yeah, so you can see all the information that you have created. It's showing up here. Alright, so once you've done that, go back to tasks, and you can save the file here by clicking on so I'm going to analysis and model output. Save. So yeah, so this step automatically saves the model. So I want to run the model through Compute Console. So if you can see, the model has been saved here, and there is a Fatigue PM include. So it is an include file that's created here. So if I go to this model here, so a fatigue subcase has been created here, and all the related fatigue cards have been outputted into this include file here. You can see here, so there are table, the load versus time history curves have been created, multiple cards have been created here, and all the fatigue parameters are all saved into this include file here. Conveniently, you can check those if they're, and modify them here if necessary. All right, so let's run this model here. So if you go to Compute Console, I'm just selecting the folder here, selecting this model output.fm, click on OK, and then run analysis. So give us a minute or so for the model to complete, and then you can see the fatigue has been solved. You can see all the damage and life information here. You can check in the out file also the information. All right, so the run has been completed. So let's close this window, minimize this. So you can load a HyperView session. So I'm closing this. So let's launch a HyperView session here. I opened a new window and launching a HyperView session, loading the results. So you can see this, the results are outputted. You can just select the H3D file and then click on apply. So this has multiple subcases. You can see. So there is a fatigue subcase at the end. Select that and click on this contour, and you can see damage and life here. So select any of those. Select this life and components displayed. Apply. All right, so you can see so you can see the life here for some of these parts, and yeah, you can click on the results here. Oh, sorry. You can click on the table view to check the results for the life of these parts here. So the life is 132 for some of these parts. So you can check on that, and you can adjust the scale here. So I'm selecting. So there are a couple of elements which are less than 1,000 cycles. So maybe I can try to modify the design in these areas based on your requirement. And you can also measure by clicking on this. Select the click on this element contour and highlight to see it automatically creates the description and the value annotation. So yeah, it's very easy to set up. So you can use EN based, SN based, or a factor of safety approach for fatigue evaluation. And if you have any questions, you can reach out to Altair support, or you can also post your questions in the comment section below. You can also visit to Altair how to channel YouTube channel to see more content like this and more learning tutorials. Yeah, please visit Altair how to channel. And thank you so much for watching, and please subscribe and like the video if you like this content. Thank you so much.